Hi all, welcome back to software engineering course. Let's get started. Next what we study is like coding standards. Okay, so there are few coding standards. You cannot say suppose there is variable names, there are commands. You cannot give whatever comes to your mind. There is some rules for that. So we will see those things now. So the programmers spend far more time reading a code than writing of it. So, over the life of the code, the author spends a considerable time reading it during the debugging or enhancement of the code. So, people other than the author or the developer, they also spend considerable effort in reading a code because the code is often maintained by some other than the author. The developer, the author of the code would be different, and the maintenance or doing the maintenance of the code will be done by different person. Okay, so in short, it is the prime importance to write the code in a manner that it is easy to read and understand. Your coding standard, it provides rules and guidelines for some of the aspects of programming in order to make it easier to read the code. So first one, the naming conventions. So here we have some standard naming conventions that should be followed while doing the programming. So your package name, it should be in the lowercase like this, my package or edu dot this one. So your package name, it should always start with a lowercase. Okay. Then the type names should be the nouns and should start with the uppercase. The type names, example, you have day, date of birth, event handler, like this. So the first letter of the word should be capital. The variable names should be nouns, starting with the lower cases. So something like this one, name, comma, amount, right? The constant name, this is not it should be all upper cases. Remember, these are all for Java programming. Okay, so constants should be in the capital, like this one, pi. Method names should be the verbs starting with the lower cases, like this, get value, set value. Then private class variables should have this underscore suffix, that is private int value. Then you have this suffix. Again, some in some standards it would be like prefix. Okay. So next is variables with a large scope should have long names. Like variables with a small scope can have short names. Loop iterations should be ijk, etc. So the next is the prefix. The prefix is this one. Okay, is a prefix here. It should be used for boolean variables and methods for avoiding confusion. So boolean such as is status, it should be used instead of the status, just the status. So if it is a negative boolean variable names, then you should use something like this, is not correct. Okay. Then the term compute, this one, it can be used for the methods where something is being computed, like find main, find factorial, something like this one. Your exception classes should be suffixed with the term exception, that is array out of bound exception, null exception, stack overflow exception, something like this. Next, we will look into the files. So what are the coding standards for using files in Java? So your source files should have the extension .java. This is a known thing, right? Then each file should contain one outer class and the class name should be same as the file name. Remember, the class name should be same as the file name, otherwise it would compilers would throw you the errors. The line length should be limited to less than 80 columns and special characters should be avoided. This is while naming of your files. Okay. Then we have statements. Now these guidelines are for the declaration and executable statements in the source code. So some examples we are it's given below. So however, so that not everyone will agree on these statements. So that's why the organization, they'll generally develop their own guidelines that can be followed without restricting the flexibility of the programmers. So we'll go through these statements one by one. So variables should be initialized where it is declared, and they should be declared in the smallest possible scope. So Whenever you want to, we have a bad habit of declaring the variables first, and in the middle of the program we will initialize it and then we will use it somewhere later. So that should be avoided, and we should initialize the variables wherever it is declared. Okay. The next one is declare the related variables together in a common statement. So say suppose you want to read 5 numbers from the user. So instead of writing int num1 somewhere, int num2 somewhere, int num3, in a different line. So instead of having 5 lines for 5 statements, what we can do is like in a single statement you can have those variables like int num1 comma num2 comma something like that. Then unrelated variables should not be declared in the same statement. This is straightforward. Okay. The class variables should never be declared public. Use only loop control statements in a for loop. Then the loop variables should be initialized immediately before the loop. Okay, this is important. Wherever you have the loop, just immediately before the loop, initialize them. Avoid using the break and continue statements in the loop. Then avoid making use of do while constructs. Avoid using complex conditional expressions and avoid executable statements in conditions. Okay. The next is commenting. So there are again few guidelines for commenting and layout. It is not like that you can write anything or wherever you want to comment. Okay. So these comments are the textual statements that are meant for the program reader to aid the understanding of the code. Right? The purpose of the comments is not to explain in English the logic of the program. If the logic is so complex, then it requires the comments to explain it. So it is better to rewrite and simplify the code instead. So the comments should explain the what code is doing or why the code is there, so that the code can become almost standalone for understanding the system. Your comments should be generally provided for blocks of code. In many cases, only comments for modules need to be provided. Getting it? So we will discuss now the commenting guidelines. So single line of comments for a block of code should be aligned with the code they are meant for. So wherever you have a block of code, you can have, before, say suppose you have a module or a function, you can just before the function you can have a single line comment. There should be comments for all major variables explaining what they represent. So wherever you have variables, and if you think it is major variable or it is doing a task, then you should have a comment saying that what that particular variable is doing. A block of comments should be preceded by a blank comment line with just this forward slash and star, and ended with the line containing star and forward slash. This is how between these two symbols you have to have your comments. So the trailing comments after the statements should be short on the same line and shifted far enough to separate them from the statements. So this means whenever, say suppose you have a for loop and you want to have a comment in front of that, what you have to do, you have to give some spaces, then you have to have the comment. Again, do not, the single liner comments should be short. Do not explain everything into it. It should not be like scrolling to the right side or scrolling down or something. Better to have it in the same line. The layout guidelines, it focuses on how the program should be intended, how it should use the blank lines, white spaces, etc. to make it more easily readable. So your indentation guidelines are sometimes provided for each type of programming construct. So most programmers learn these by seeing the code of others and code fragments in the books and the documents, and many of these have become fairly standard over the years. So that's the layout thing, that is the indentation one. Okay. So now let's move on to developing of the code. Till now we have seen some good practices for development, or when developing your code you have to follow some of the good practices, the indentation, comments, layouts, these are things we have seen, right? So now we will move actually into development of the code, how to develop a code. So your coding activity, it starts whenever you have some design in place. Okay, so first the client gives you the requirements, Then you do the analysis of that. That is your SRS will be done. You do the analysis, then architecture, and then your designing comes into picture. So once designing is done, your coding activity starts. Okay. So it is not like that. Whenever you have the design in place, the developers directly jump on to development. No, it is not like that. So the modules will be divided among the developers. There is no hard and fast rule that there are few developers and they have to do all the coding activity. No, it is not like that. So the modules in the designs are assigned to the developers, and the assigned developers will start developing of the code. So when these modules are given to the developers, right, how they have to start the development, how they have to do the coding. So there are again some processes they have to follow. So there are variety of processes or n number of processes are available so that the developers use this process and then develop their code, right? Here we discuss some of the effective processes that the developers use for incrementally developing of the code. Okay. Now we will see what is incrementally development or incremental coding process, right? So here you have the flow chart, which will be easier to understand. First, let me discuss this one, and then I'll explain this flow chart. Okay. Now, the process is followed by the many developers is that they write the code that is assigned for them, that is the module assigned for them. They start writing up the code. So when the coding is done, they do a they do a unit testing on it. Unit testing means they check that program, whatever they have written, they try to find out if there is any problem with that, any issues, are there any bugs. So they verify their own problem. Now that is called as unit testing. The code is then checked in into the project repository to make it available to others in the project. This means, say suppose there are 5 developers in a project, okay? So say these 5 developers are given 5 modules to implement. Each developer is given one module to implement. Now, say suppose the developer one, he has coded the module. Now he has unit tested his module. So once this is done, what he has to do is like whatever the code he has written, he has to post it into the repository, or he has to save that particular code what he has written into the repository. So what will happen now? So that your developer one has put his program into the repository, right? Now this repository is common to all the members of your project. So once he has posted something, so the other developers can look into the repository, and if they need, they can use his program and they can start enhancing it, or else they can attach that module to his developer one's code. Okay. So a better process for coding, which is often followed by the experienced developers, is to develop the code incrementally. That means to write the code for implementing only a part of functionality of the module. Then this code is compiled and tested with some quick test, like to check the code and that has been written so far. So when the code passes this test, the developer he will move on to add some more functionality to the same program or to the same code. Again, it is tested. So what we can say is like the code has been developed incrementally. So the previous thing what I had given you example that the entire module would be done and then the developer would be testing it. But now I am saying the experienced developers what they do is like they write small, suppose a module is assigned to them, they do not write the entire functionality of that module. They again divide the single module into multiple uh, units or multiple parts. So they start developing that single part, they test it, then again they start with the coding of the second part, then again they test it. Likewise, they incrementally, step by step they will write the code, they test it so that the entire module will be ready. Now the advantage of developing the code incrementally, with the testing being done after every round of coding, it is to facilitate debugging. You're incrementally developing the code, it helps in debugging. That means whenever the test is done on that particular part of the code. If there are any issues, it is easier to fix rather than at the later stages. Okay, so for this purpose, there could be some automated test scripts that can run the test cases with a click of button. This means, so whenever the developer he writes a part of code, instead of manually doing the check again and again, they can automate it. Instead of manual thing, they can automate the testing part of this one. So with these test script, testing can be done frequently as desired, and new test case they want to add, it can be done easily also. Now these test cases, this will be test scripts, whatever they have written, this will be enhanced in future. Why? Because right now they have used that script for a single module or functionality. In the future, you might add or enhance the same script or the functionality, so that your script again has to be re-verified. So these test scripts can also be used with some enhancement for the final unit testing, that is for checking the entire module. Okay, now I'll discuss this flowchart. So whatever we have discussed, it is simply put up in this flowchart. If you understand this flowchart, then it is like you have understood this incremental coding process. Okay, so the process, it starts with the specification of the module. That means the developers will be given some modules to code. First, what they will do, they write some code to implement some functionality. Inside that module, they again split up the single module into multiple parts, and then they will write some part of that module. Okay. Now, once it is done, they do testing of it. Okay. Now, next what they will do, say suppose once code is written for one part and they have tested, now they will enhance it. That means they will add new functionality. Okay, and then test it again. So this process continues. So say suppose they have completed of one module. For example, they have completed 5 functions in a module. Now what they have to do, the developer, they have to run the test script. So they have to run the test script of the entire module. Now if there are any errors in this, if there are any errors here, okay, they have to fix it. Once they have fixed it, they have to run the test script again. Again, check for if there are any errors. If there are no errors, then you have to check if all the specifications are covered in that particular module, or all the functionalities are covered in that particular module. If yes, that is a exit. That means the coding of the module is done. If no, if you have missed some of the functionality, you have to go back again, you have to write the code for it, then test for it, then run the test script again, then you have to check for all these conditions again. Getting it? This is one way of incrementally developing the code. The next one is test driven development, TDD. Okay. Now it is a coding process that turns around the common approach to coding. So here what will happen is, instead of writing the code first, the developer what he or she they will do is like, they first write the test script, then they will write the code to pass those scripts. Okay. Now the whole process is again done incrementally, with the test being written based on the specification, and coding being done, or coding is done so that the code will pass these tests. So let me explain this flowchart for you. So for example, consider the developer has given one module which contains 5 functionalities. Okay, a single a single module, it contains 5 functionalities. Now the first starting step over here is specification of the module. That means a module has been given to a developer to develop the code. Now say suppose this module has 5 functionalities. Now the developer, what he has to do first is, he has to write the test scripts for the functionalities. Say for one functionality. Okay, he has to write first the test script. Now what is a test script? So say for example, you have the login functionality in this module. So first what the developer has to do, he has to write the test script. That means he has to have a document and he has to write down the scenarios for the coding, like how the login will be tested. Say suppose the action is give or enter correct username comma correct password. What is the output? It should be successful login. Okay, this is one scenario. Then give correct username, wrong password. What should happen? Error message should come. This is the expected output. Then give wrong username and give correct password. What should be the condition? It should be again error message. Give both of them wrong. Then again it should throw you the error message. Now these four things we call them as scripts, test scripts, okay, or the scenarios which your developer has identified for one function. Likewise, he has to write the functional, or for all the functions he has to write test scripts. Now once he has done, he is done with writing the scripts. Now he has to start coding. Now he should write the code such a way that these all the things or the scripts whatever he has written should pass. Okay, getting it? So if he has written if he has been assigned five functions, that means he has to write first five test scripts. After that, he has to write the code for those five test scripts such that whenever the code is complete and he tests that all these things, the test scripts should pass. So say suppose he has done the coding activity. Now he has to run the test script. Say suppose while running of the test script, that is nothing but just checking whether there are any bugs or not, whether these things what is expected is actually happening or not. Okay. So say suppose whenever the developer is running of the scripts, he has to check whether there are any errors. If there are any errors, he has to fix them and he has to again run the test scripts. If there are no errors, then he has to check whether he can make any improvements to the code he has written. Okay, like can any easier data structure can be implemented apart from say for example tree, or can the memory be utilized less, something like this. So he has to check whether the code needs improvement. If he thinks yeah some improvement can be made to that code, then he has to improve the code. After improving of the code, he has to again run the test script. Say suppose there are after improvement there are no errors, and he feels that there are no improvements. So then what happens? Then he has to check whether he has covered all the specifications from that module. If he has covered everything from that module, then the module is completed. Coding of the module is completed. If no, if he has missed some functionality, he has to again go back to the first step. Again, he has to write the code, write the script, then write the code, then verify, run the scripts, verification. Now this process continues. Okay. Now, so the first here in the test driven approach, it says that you need to write just enough code to pass the test. By following this, the code is always in sync with the test. So this is not always the case with the code first approach, right? In which it is too common to write a long piece of code, but then only write a few tests which cover some part of the code. The test-driven development it is adopted in extreme programming methodology, that is XP. Okay. Again, here the first test cases, whatever they write, it is for the main functionality. So the code for the higher priority features or the main functionality is covered first, then the lower priority items will be taken. Now, the completeness of the code it depends on the thoroughness of the test cases. If suppose you missed writing any of the test cases which is important functionality, so if you miss the test case, that means you will not code it. So that actually means that you have not coded the main functionality of the system. So this is one disadvantage. So whenever you are writing the test scripts first or the test cases first, you have to make sure all the activities or all the functionalities are covered. Then start writing the code. Okay, getting it? The next one is pair programming. So this is the third approach of developing the code. Now this pair programming it is mostly used in extreme programming or your agile methodology. Okay. So what will happen in this case is, instead of a single developer doing the code or developing the code, what has been done is a pair of programmers, a pair of developers will be assigned for writing the code. That means two developers are assigned for one module. So these two developers are responsible for that coding of that particular module. Okay. Now, so the process it starts there. How it should start is like one programmer or the one person, he will type the program, and the other person he'll actively participate and constantly review whatever is getting typed. So whenever one developer is, he is writing the code, if there are any errors that are noticed by another person, so then and there, the error is pointed and it is corrected. So, so if needed, these pair, the two developers, they will discuss the algorithms, data structures, or the strategies to write the code. So again, this role is rotated frequently. That means, say for example, one week the developer one has written the code and the developer two, he has just reviewed it. Okay, he has constantly participated in review process. The next week, what would happen is developer two, he will write the code and the developer one will review what developer two is writing. Okay. Now the basic motivation for pair programming is that code reading and code reviews can be done, or they have been found to be very effective for detecting of the errors whenever we have this pair programming, because one is writing the code or typing the code, the other one is reviewing it. If there are any errors, they will find out at the same moment. Okay. So why this is coming into picture, or why this is of importance, is like we have the traditional development method wherein you first write the code, then it is getting reviewed by the other programmer. But here we have, at the same time, the coding is done and parallelly the reviewing work will also be done here, like your incremental development and testing. So this is also, it's like something incrementing itself. Okay, that means coding and reviewing is taking place parallelly. So besides the ongoing code review, these two programmers, they apply themselves to the programming task at the hand, which is likely to result better decisions being taken about the data structures, algorithms, interfaces, logic, special conditions, etc. So, but the drawback over here is that it may result in loss of productivity. Okay, so it is clear that the pair will produce a better code compared to the code being developed by the single user, right? But there may be, productivity issues. Say developer one, he is developing continuously. The developer two, who has to review the code, he is not actively participating in the task. So the productivity might go down here. Again, there are issues related to the accountability and code ownership, particularly when the pairs are not fixed and they are rotated. That means, say suppose whenever there occurs a bug or missing of the functionality, so who is responsible? Who has missed the code? Right? Is the developer one or the developer two? They will not, anyone as a developer, if there is any missing of the functionality or any issues or bugs are found out in the code, they will not be able to receive that. So now the accountability of the code or the ownership of the code would be a problem here. Okay. Now these are the three approaches for incrementally developing the code. Right. Now let's have a quiz. The question is, in which approach does the developers write test scripts first and then they'll write the code? You have got a minute of time to respond to this one. Okay, time up. That's it for today. We'll conclude our session. Thank you.